In this lab session, I will be using EC2 instances as compute platform. Before we deploy our code using CodeDeploy, we need to have our compute to deploy against, right? So first, let's create a couple of EC2 instances and get our load balancer ready. By now, you must be familiar with launching an instance. I will quickly run through, except for the configuration we are interested in. I'll click on EC2 in here and click on Launch Instance. We'll choose Amazon Linux to AMI and T2 Micro. And in here, I will set the number of instances to 2. And I will choose a role which I created. Let's take a look at the policy attached to this role. I have assigned this managed policy, which basically provides read access on S3, as we would like to download our code, which is being stored on S3 bucket. And then remember the code deploy agent I talked about during our theory lecture, which needs to be installed on the instances, without which code deploy cannot detect the instance. I'm going to provide some user data in here to install the agent along with some other installations. Let's take a look at the user agent script I'm going to provide. These commands in here will install the code deploy agent. The bucket name varies based on the region. I'm using US East 1. You can change the respective region name in here. And rest of the commands in here are to install and set up Apache HTTP web server so that we can deploy our React code. And the last couple of lines are to create an index.html file and serve it up when the root URL is accessed. All right, let's copy this and paste it under user data in here. Click on next. Storage, leave as it is. And tags, this is important. Make sure you provide the same tag value for all the instances in your fleet to which you would like to deploy. We will be using this in our code deploy configuration. And for security group, I have already created one. So let me select that. So this basically allows access for the load balancer on port 80. And let's quickly review and launch. Choose an existing key pair and click on launch. All right, the instances are being created. Okay, the instances are now in running state. Let's add them to the target group for our load balancer. So if I scroll down to the load balancer, I already have this load balancer created, which is attached with the target group, which is Wiz Demo Code Deploy. So let's select this target group. And if I go to targets, there are none right now. So let's click on edit. Let's add our 2 new instances to the target group and hit save. Well, the status is initial. It will take few seconds to send the ping and get the right status. Let's refresh, and there the status is now healthy. And if we go back to the load balancer and grab the DNS name, access it in the browser, there it is. You can see our index.html, hello world, which we created in our user data script. Now to these instances, we will be deploying our React code, which should eventually look something like this. So if you remember our code build lecture, this is our React code. There are no changes to the actual code, but I have added this appspec.yaml file to be used by CodeDeploy. In this YAML file, under Files object, we can configure which files from our application revision should be installed on the instance during the deployment's install hook event. Well, install hook event is controlled by CodeDeploy and we cannot provide under this hook section. So that's why you do not see install hook in here. And for our code, I am asking CodeDeploy to install this build directory into this directory. And under source, you can either provide a folder or a file from our revision, If you want everything from your revision to be installed, simply put a forward slash for Linux and a backslash for Windows. And under hooks in here, I'm using a couple of hooks. Application stop to stop our Apache web server, which will occur before install, and then application start to start the web server back after the installation is complete. And I made a small change to our build spec file to create artifacts, including this app spec file and the scripts folder. And so I also created this scripts folder, which contains our stop and start shell scripts. So these are the scripts we provided in our AppSpec YAML hooks, which basically stops and starts the Apache HTTPD service. And in AWS Code Build console, I have built this again as a zip file because for code deploy, remember the format should be either zip or tar.zz. And if I download this and open it, you can see three items: build, app spec, and scripts, which we configured in our build spec YAML file. So to reiterate, I have added app spec YAML file and couple of scripts and build the code again using code build, just so that we need these files for our code deploy. All right, now this is the code revision we are going to deploy to our EC2 instances. So let's go to code deploy. And under applications, we can list all the applications. We can create an application from here. So let's click on it. Let's give it a name. And let's choose the compute platform as EC2 or on-premises. And hit create application. We have the application created. Now we can create deployment groups within the application. So let's create one. Let's give it a name. And a code deploy service role is required to call AWS services on behalf of you. Let's take a look at the role I created and the policies assigned. This is the role I created with service as code deploy. And if I open and take a look at permissions, I attach this managed policy, AWS Code Deploy role, which contains various actions to perform during deployment. So let's go back to Code Deploy and let's select the role which we just saw. Now these are the deployment types we spoke about. Let's first take a look at in place. We will visit blue-green later. Then we will need to select the environment on which we would want to deploy. You can either choose an auto-scaling group or identify EC2 instances based on tags, or register on-premise instances and configure them here. But remember, in any case, you need to install the code deploy agent, what we did while launching the instances. Let's choose via tags. So let's select EC2 instances option and provide the key value which we used while launching the instance. And here is where we can choose default configuration, or you can create a custom configuration on your own, wherein you can specify minimum healthy hosts in percentage or number, so that when performing deployment, Code Deploy will ensure you have these minimum hosts available for request traffic. Let's leave it as all at once option. So remember this option. We will talk about this later. And the next one is load balancing. It's an optional field. So if you enable, Code Deploy will perform additional hook events. So let's choose application load balancer and choose the load balancer to which we attached our instances. And under advanced, you can create a trigger for each of the hook events so that you can receive an SNS notification after an event completes or the entire deployment completes. You can also create CloudWatch alarms from here and disable or enable rollback for a deployment. All right, let's go ahead and create the deployment group. We now have the deployment group created. So what is our next step? Yes, we need to create a deployment now. So let's go to the deployments tab and let's create deployment from here. Let's choose the deployment group from here, which is our new group which we just created, and then the revision type. We can see Amazon S3 and GitHub, but not the Bitbucket. Well, under GitHub, you can also provide Bitbucket repo URL. They essentially follow the same Git functionality. So since we have our code build output in S3 bucket, let's choose S3 and let me provide our code build S3 path in here. And under revision file type, as of today, zip or tar.zz types supported. So let's choose zip. That is what we created through our code build. And you can override certain settings which are configured on the deployment group. All right, let's create the deployment. So once the deployment is created, CodeDeploy will automatically kick off the deployment. You can see the status is in progress now, and CodeDeploy detected 2 instances. And since we chose the deployment configuration as all at once, application is getting deployed to both the instances at the same time. You can view the event status from here, the hook events that will be executed in this order. And if we go back to EC2 and to our load balancer target group and select the targets, you can see the status as draining for both the instances. So if I try to make a request to this load balancer, let me refresh this. You can see service is temporarily unavailable. This is because our both instances are getting updated at the same time, and they are being taken out from the load balancer. And that was because our deployment configuration option was deploy all at once. You can list deployment configurations in here. So if your application cannot tolerate downtime, you can prefer the options which will have minimum healthy host as non-zero. These 3 are for EC2. You can also create a configuration from here, which is same as what we have seen while creating the deployment group. And these configurations are different between EC2 and AWS Lambda. So if we choose AWS Lambda as a compute platform, the deployment configuration specifies the way traffic is shifted to the new Lambda function versions in your application. So with AWS Lambda, with these configurations, there are 2 ways the traffic is shifted to your new Lambda function. The first one is canary. With canary, traffic is shifted in 2 increments. So in this example, first 20% of the traffic is shifted to the updated Lambda function, and after 30 minutes, rest 80% will be shifted to the updated Lambda function. And if we choose linear, and under linear, traffic is shifted in equal increments with an equal number of minutes between each increment. In this example, 20% of the traffic is shifted first to the updated Lambda function, and after 30 minutes, next 20% is shifted, and after next 30 minutes, next 20% is shifted, and so on until the entire traffic is shifted to the updated Lambda function. And if we do not want any of these 2, we have a default option, all at once. All traffic is shifted from the original Lambda function to the updated Lambda function version all at once. And for AWS Lambda, you have other default options for linear and canary as well, which you can choose from. And for ECS, there is only one option, all at once, and we cannot create a custom configuration for ECS. All right, let's go back to our application and then to deployments and see the status of the deployment. The status is still in progress and the event is block traffic. Well, it usually takes a few minutes to drain the instances from load balancer. So let's come back after the deployment is complete. All right, the deployment has been successfully completed. And if I go to any instance events, you can see all the events are succeeded. Now, if I go back and hit the load balancer URL, there it is. Our user component UI has been successfully deployed. And if we go back to the load balancer under EC2, our instances are reporting healthy status. Excellent. We deployed an application using AWS Code Deploy. Now let's see how we can deploy using blue-green deployment type. Let's go back to EC2 instances. Let's terminate one for simplicity purposes. And from our active instance, let's create a new autoscaling group and attach our instance to it. So under actions, go to instance settings and select attach to autoscaling group and attach instance to new autoscaling group. So let's give it a name and hit attach. Let's navigate to autoscaling groups. And you can see our new autoscaling group in here. Now let's go to Code Deploy and go to applications and select our application and click on edit. Let's change our deployment type to blue-green. You can either provide an autoscaling group or manually provision instances. Let's leave the option as autoscaling group. And let's select our newly created autoscaling group in here. So what CodeDeploy does is, it uses this autoscaling group which we just selected and copies it and creates a new autoscaling group and launches the replacement environment using this autoscaling group. And in here, you can specify how to route traffic to the replacement environment. You can either choose to route immediately after the replacement environment is available, or you can delay it by a certain time. And then in here, you can choose whether to terminate the old environment or keep it. And if you want to terminate, you can delay it by a certain time. Let's leave rest of the settings as is and save changes. Now let's create a new deployment for the blue-green deployment type. Choose our deployment group. We will deploy the same code again. So let's give the same path. Revision type as zip. And let's choose this option, override content if same content exists, because we are deploying the same code again, just to make sure it doesn't fail. Let's create deployment. All right, the deployment has started. Now these are the steps which are performed in blue-green deployment. First step, which is in progress right now, is to provision the replacement environment based on the autoscaling group we selected. And second step is to install the application on the replacement environment. And then third step is to reroute the traffic based on our configuration. And last step is to terminate the original instances if we chose to terminate. And on the right, you can monitor traffic shifting progress. Our first step is still in progress. Let's go to EC2 instances. Let's refresh to see if our new instance is listed in here. All right, there it is. Let's select this new instance. And if we go to tags, well, for instances provisioned by CodeDeploy, we will have this tag with this as key and value as our deployment ID. If you go to load balancer target group, it still contains old instance because traffic rerouting step has not yet started. Let's go back to CodeDeploy and see the progress. All right, step 1 is complete and step 2 is in progress. Let's come back after step 2 is complete. All right, step 2 is complete as well and step 3 has started, rerouting the traffic. If we go back again to our load balancer target group and refresh, we can now see the new replacement instance has been added to the load balancer to take the request. And the other instance is also active. Let's refresh again. And you can see our original instance is in draining state. So the code deploy will first add the new instance to the target group, and then it drains the old instance in order to make sure the requests sent to the load balancer are never affected. And if you go back to the code deploy and look at the monitoring status, you can now see the traffic is being currently sent to both the environments for a short while. And if we go back and refresh our load balancer URL, it works. All right, step 3 is also complete. And now entire traffic is being sent to the replacement environment. And step 4 has been completed as well. And the original instance has been terminated. If you go to our load balancer target group, refresh it, you can see the original instance has been removed and it only contains the new instance. And if you go to the instances, refresh our running instance list, and you can see the original instance has been terminated and only our replacement instance is running. And if you refresh the load balancer URL again, it works perfectly. So the main thing is for the entire deployment, the request to this URL remained uninterrupted and the switch from original to replacement environment was transparent to the users. That's the main advantage of blue-green deployment. You will never have to bring down the environment which is serving the requests. So we have seen how to deploy an application with both in-place and blue-green deployment types. Well, remembering all these configurations could be a little overwhelming. I suggest you to practice different combinations of deployment configurations to get acquainted with AWS Code Deploy. Hope you enjoyed this lecture. Thanks for watching.